So I really was serious. I'm just going to take it easy on you guys today, and we're not going to do a whole bunch just because I want to keep taking these one chunk at a time to make sure you understand what we're doing so I can grade it before we go on to the next one. So therefore, we are going to talk about flatness today. So when we were talking about straightness, just a reminder, we're talking about straightness going just one direction and really just taking any cross section. Let me see if I can find that slide that showed that well. Of course I can't. It'd be too easy. There we go. So when we're saying the straightness of this top surface, first of all, we're saying the straightness as it goes left to right in this direction. And then as I look at the side view, it's really just talking about any given cross section has this straightness value applied to it. So what if I wanted to control the straightness of this side as well? I could put another straightness value on this one. If they were the same value, then essentially what I'm doing is creating a flatness plane that they need to lie on. So that's what we're going to do today, is really just control it in all directions and use a plane instead of just any given cross-section line. So let's jump to it. Okay. Pretty similar in what we're going to be doing. Again, this time we're just using the flatness symbol. So when I see the flatness of 2/1000ths there, again, I'm going to consider, instead of two lines, actually two planes. So once more, I have my minimum size and my maximum size based on my tolerance, in this case 6/1000ths, and anywhere in between there would be a good part. But now I'm adding on top of that a flatness value of 2/1000ths. So the tolerance, or excuse me, the surface needs to fall within that 2/1000ths tolerance at all points. So in a sense, straightness in every direction, if you will. In addition to calling out just the flatness overall, we might have a further tolerance to indicate that any given surface area cannot vary more than a certain value. So in this case, what we're saying is that overall, this can you can have variation of up to 0.01 and it still be a good part. However, in any 1 inch by 1 inch surface, it can't vary more than 2/1000ths. So overall, across the whole part, it can vary up to 0.01. But in any given 1 by 1 square, it cannot vary by more than 0.002. So that just controls it even further. So does that make sense so far, what we're talking about there? All right. Let's take a look at the drawings for the day. So we're going to be in the 16-3 folder, and I think we're only doing 3 of these. One of them we're not going to do. 3, 4, and 5. So don't do 6. I can't even, oh, 6 is 6 that wants you to draw the region, and the region is so small it's really hard to draw. So we'll start with 203 here. Okay, so you're told to add a flatness tolerance of 0.03 to the base of the flange. So this is the base of the flange. So since it rotates it around, it doesn't matter if you do it to this edge or one of these edges. It's all good. So next, we are going to add a flatness tolerance to surface B. And the maximum flatness is 0.010 inches for the entire surface. And then in any 2 by 2 area, you're going to have the 0.05. Or 005. So let me show you how you're going to create this control frame. So using the dimensions drop down, looks like I accidentally just pulled that out. Oh man, what did I do? I just totally lost my annotation. I accidentally dragged it out. Let me change my workspace and change it back, and hopefully it comes back to me. Okay. So I just did it again. Use my control frame, and then just like we did last time, we're going to use the flatness instead of the straightness. And then we'll put in the tolerance for the overall. And then in the box right below it, then I'm going to put in what the tolerance is with the slash and then the space. Now, I don't know if that's the correct value. What was it? 0.005. So I'll put in the correct value to match. And then remember when we're putting in X for by that we put spaces in it. 2 by 2 should have spaces in between it. Now, if I click OK, I get this little control frame that looks like this. That is not correct. I'm going to double click on it, and I'm going to put the flatness symbol in the second row as well. And as you can see, it combines those into one note. So that's the look that this symbol is going to take. And then, of course, you just need to point it to the correct surface. And then the third one. So for this one, you're told that, so we've got two parts that are going to fit together. Part 1 is going to fit into part 2, and there's going to be a minimum clearance of 0.001 and a maximum clearance of 0.005. Add the tolerance dimension to part 2, and then add your flatness tolerance of 0.001 to the two surfaces of each part. So all the mating surfaces need to have the flatness tolerance of 0.001. So this surface and this surface, this surface, and this surface. And then in addition, you are to throw in some tolerancing to dimension what this part should be. So we've got our min and our max. We've got our maximum clearance value, and then the minimum clearance value. So you should be able to find the upper and lower dimensions of this feature. And then add in your flatness. So feel free to do multiple leaguers. If you want to do one control frame and point to this surface and point to that surface, that's acceptable. And then you can do your dimensions as limits and just choose the upper, show the upper and lower instead of doing the plus or minus. That's all I got planned today, and partially because we're going to get into MMC and LMC stuff next class period, and I really want to focus on that, and I don't. And there's quite a few exercises, so I don't think we'll get through them all today anyway. So we'll start with that for today. So those three, don't do the fourth one in that folder, and again, put in your initials and print them on the LaserJet.